Okay, so now let's go ahead and talk about graphing by transformation. Now, this is one that we've discussed a lot. I'm afraid a lot of people would skip this particular video feeling like they've got it down and are likely to make some careless mistakes on a particular style of question on our test. So I want to make sure I highlight that. It's actually not a throwaway video at all. There's some pretty significant details here. So I'm going to jump right into a Desmos thing to see if we can use this as a simple way to demonstrate. So I think throughout this time, we have established pretty well that if you have something like f of x plus 2, I believe that all of you in the room would understand that that would take the graph and move it to the left 2 units, just point by point, moving it to the left 2 units. Whereas if we had an x minus 4, I think we all know that it would move it to the right. I think we've also established pretty well that if we put a 2 in front, that would actually multiply the y values by 2, so the x values would remain unchanged. So notice this x value is here. The x value right here, y was, it was 0, so if I doubled 0, nothing happened. All of those things, I think we landed the plane reasonably well. So I'm going to turn this off and put a couple of things in here, and I want to see if you can think about how you would describe this particular transformation. So if you want to think about it and pause the video for just a moment, that would be a great idea. All right. So here's what I noticed, is that on the original graph, it had a nice little coordinate, which was -4, comma, -3. Simple little idea. Let's go ahead and go another one, which was the coordinate 0, comma, 1. So this is, again, just something to kind of help emphasize what we did. Now, what I see in this particular story is somebody multiplied the y values by 3, and then they subtracted 5. So in that first equation, I'm going to go ahead and set myself up for both of them. But in the first one, if I multiplied the y value by 3 and then subtracted 5, if I multiplied this by 3, that's -9, and I subtracted 5, that would be -14. And in this one, if I multiplied it by 3, I would get 3, and subtract 5, I would get -2. Now, the part that kind of messes people up, and I think we've talked an awful lot about that, is the fact that we don't want to have anything attached to x. So I should put a parentheses right here and make this into the number 2. Now, our last little thing is that means this is opposite land, which means if I've done this thing correctly, I should divide the x values by 2 and then subtract 2. So -4 divided by 2 is -2. -2 take away 2 should be, in fact, then -4. So that one coordinate, -4, -3, should turn into this one. And then last, on the value 0, if I cut it in half, I can remain 0, and then I go to the left 2, and I get -2. And so if we have done it right, those values should show up on my new graph, and you can kind of see that they do. Now, one of them is pretty far down off the screen, but you can still see that it's there. Okay, now, the part that I was actually more concerned about as I started preparing this little idea of a video is if you had that function f of x, what if someone says, hey, come up with a new equation raw that does a couple of things? So what I'd like to do is just go over how you could create that situation. So we had f of x. I will share my paper here in a minute, but I just need to write down the equation that I had. Okay, so let me describe what I'm after here. Let's get back here to the share screen. Okay, so let's say I wanted to move this particular idea to the left 5 units. In other words, I wanted to take f of x plus 5. Now, historically, I've had a lot of people that totally understands this is what that says, but they have trouble actually applying it in here. So f of x plus 5 literally says go in, take that original x that I had in my story. Notice I wrote f of x as it was, but let's replace x with x plus 5. And that created the new equation, x plus 9 minus 3. That would have taken this parent function and moved it to the left 5. What if I said, hey, you know what? Here's what I want to do. I want to vertically stretch by a factor of 2 and go down 3. Now that's a lot of work right there, huh? So vertically stretch by a factor of 2 and then go down 3. Well, that would mean I'd take 2 times f of x and go down 3, where f of x is this entire thing. So you're going to watch that it's 2 times f of x. So this entire piece is this f of x that I started with. So that being stated, I actually have 4 of those roots. I also have a -6 here with another -3 right there. And so this would result in a brand new function that is related to this by stretching it vertically and going down 9. Now, the last one that I was going to show you is what if we did something that was very, very simple, which is to flip or reflect across the x-axis, and then let's look at the y-axis. So anytime you choose to flip something across the x-axis, that would be the opposite of f of x. If we're going to flip across the y-axis, that's f of -x. Well, what I've noticed is in the past, I have a lot of students really struggle with this one, but they're not thinking about what happens. It's the opposite of f of x. It's the opposite of f, but f is this entire thing right here. So ironically, when I flip it, it does do this, and most students do that part correctly, but almost no one realizes that that 3 has to be flipped as well. Now, as I did in the other problem, could you graph this on your calculator and graph this on your calculator and see that they are, in fact, reflections across the x-axis, that they look the same under that reflection? And then the last one says take f of -x. So we take f of x, and a composite tells you to replace x with its opposite. So in other words, there's really very little to do with this problem to reflect it across the y-axis. I literally only need to make x -x. So this is actually a pretty important one, and so I'd love to see you try as a couple of those on your own. Let's take the function g of x is equal to 6, 2x minus 1 cubed plus 8, and let's go ahead and let's move right to 1. Let's go ahead and flip across y-axis, and then flip across the x-axis. Again, go ahead and pause your video for a moment before you do that, and then we'll see kind of what happens. Okay, so let's try that. If I want to move it to the right, I'd want to take g of x minus 1. So I'm going to replace that x right there with x minus 1. So I have 6, 2x minus 1 cubed plus 8, but I'm going to replace x with x minus 1, because that's what that says. So my new equation is 2x minus 2, but there's another minus 1 right there, and I'm done. That's a brand new equation. It took the original and it moved it to the right one. Okay. Flipping it across the y-axis, that is just making the opposite of f of x, which means I'm going to have a negative, and I'm going to put all of g of x here. I should have said g right there, but that's all right. Plus 8, And so again, just like the previous problem, what's really kind of important is not only did this portion of the graph change, but so did the y-intercept. And then flipping across the x-axis is just g of negative x. So we're going to replace that x with negative x, which I'm wanting to keep the video short. So if I replaced x with negative x, that would become negative 2x. And so flipping something across the x-axis is always very quick and easy. That's a quick little look at graphing by transformation. Hopefully that helped. I'll see you on the next one.